Hello everyone and welcome to a new video. Today the topic what we're going to discuss are the properties of natural number, namely closure property, commutative property, associative property and distributive property. Now before I can proceed with the video, I would request you to kindly subscribe to my YouTube channel if you've not done yet. Please do not forget to press the bell icon. Besides that, you can find a few links. Make sure you join the Telegram group because that's the place where you can get most of the updates. So on this note, let's move ahead and understand these properties of natural numbers. Before that, let's do a quick recap. What are natural numbers? Natural numbers are positive numbers starting from 1 to 3. Whole numbers, natural numbers includes the set of natural numbers including 0. Integers are whole numbers and the negative. That means whole numbers include the entire integers, include the entire set of whole numbers with the negative signs also. And rational numbers are includes all these integers, whole numbers and natural numbers. So basically they are numbers that can be expressed as a fraction a upon b, where a and b are integers and b is not equal to 0. So 1 can be expressed as 1 upon 1, or 2 can be expressed as 2 upon 1, etc. and even negative 1 upon 1. So these also are rational numbers. So what we are going to start today and study, the first property is the closure property of natural numbers. So what does it state? It states that when we perform an operation such as addition or multiplication on two natural numbers, the result will also be a natural number. And second thing, whereas in case of subtraction or division, it may or may not be a natural numbers. That means when you're doing, let's show you with the example. It's really much clearer than trying to be theoretical over here. Let's take an addition. So what does the property state? That when you perform an operation on two natural numbers, the result will also be a natural number. So when you're adding 3 plus 5 is 8, you can see the output is natural number. Hence we called it closed. Since it's a closure property, we called it is closed for addition. Let's try out subtraction over here. Subtraction, you can see over here 5 minus 7 is negative 2, which is not a natural number. Hence we say it is not closed. Now if I just reverse this and make it 7 minus 2, you're going to get a positive 2, which is a natural number. So why we are mentioning that it is not this thing? Because you can see over here may or may not be a natural number. So when it does not hold true in any condition, it violates the condition, you call it not closed. Then multiplication, 4 multiplied by 6 is 24. So if you multiply any positive integer, you're going to get a positive natural number only. Hence we called it closed. Division, 10 divided by 3, you can see 10 divided by 3 is not a natural number, it is a rational number. Hence this is not closed for division. So this is as simple as it for the natural number. Next we move on to the commutative property for natural numbers. So what does the commutative property state? The commutative property states that the order in which you add or multiply two natural numbers does not change the result. And second, you can see over here, so a plus b is equals to b plus a. Let's check an example over here. 3 plus 5 is equals to 5 plus 3. So when you add this, you get 8 on the left hand side and 8 on the right hand side. So yes, this addition holds good for commutative property. Let's try for subtraction. A minus b is equals to b minus a. So you can see 5 minus 3 is not equals to 3 minus 5, because when you subtract 5 minus 3 you get 2, and when you subtract 3 minus 5 it's negative 2. So when you subtract one number from the other, you don't necessarily get a natural number. So that's why this property does not hold good for commutative property, that's subtraction. In case of multiplication, a multiplied by b is equals to b multiplied by a. Let's check out an example. 4 into 6 is equal to 6 into 4. So when you multiply 4 by 6, you get 24. 6 by 4 also 24. So yes, it holds good for multiplication. Finally, let's do the division. A divided by b is equals to b upon a. So 10 divided by 2 is not equal to 2 divided by 10. Why? 10 divided by 2 is 5 and 2 upon 10 would be 1 upon 5. So you see that the LHS is not equal to the right hand side, and that's what this property states. It states that the order in which you add or multiply two natural numbers does not change the result. Now in case of addition and multiplication, you can see the or when the order is changed of addition or when the order is changed of multiplication, the result is the same both on the LHS in the right hand side, but when the order is changed for subtraction and division, the result differs. Hence the commutative property is true for addition and multiplication but not for subtraction and division. Next we move to the associative property of natural numbers. So what does the associative property of natural numbers state? The associative property states that the way in which numbers are grouped in addition or multiplication does not change their sum or product. So this is the property of addition. Let's say a plus b plus c. You can see b plus c is grouped over here in a bracket is equal to a plus b plus c. So in this case you have a plus b grouped in a bracket, and on the LHS you have b plus c in the bracket, or on the RHS you have a plus b. So let's try and do a addition of that same. So let's say these are the values of a, b and c. So 3 plus 5 plus 2 is equal to 3 plus 5 plus 2. So you need know, whenever you have an equation like this, you need to always follow BODMAS. So if you are free, I mean if you are very well versed with BODMAS, you don't need to, but if you don't know how exactly to use BODMAS, there is a video which is there. You can go and check it out and learn for yourself. So 5 plus 2, first we need to solve the bracket. So 5 plus 2 is 7. So 3 plus 7 is equal to bracket again over here. 5 plus 3 is 8. So 3 plus 7 is equals to 8 plus 2. When you add the LHS, you get 10. When you add the RHS, you get 10. So this holds good associative property for addition. Now let's check the same thing for subtraction. So a minus b minus c is equals to a minus b minus c. This is how you are going to write. So let's check it out. So you write what? 5. Let the values of a, b and c are 5, 3 and 1. So 5 minus 3 minus 1 is not equal to 5 minus 3 minus 1. So first we solve the brackets. 3 minus 1 is 2. So you have 5 minus 2. And again you solve the bracket over here. 5 minus 3 is 2. So you have 2 minus 1. So 5 minus 2 is 3 on the LHS, and on the right hand side is equals to 1. So you see LHS and RHS is not matching, hence the property associative property does not hold good for subtraction. Next we move on to multiplication. So what you're going to do, a into b into c is equals to a into b plus c. The brackets are for b into c and a into b over here. What are the values of a, b and c? 4, 6 and 2. So we just replace them over here. So let's do the solve the brackets first. On the LHS you'll have 4 into 6, that's 12. 4 into 12. On the RHS you'll have 6 into 4 is 24. So 24 multiplied by 2. So when you check the result, 4 into 12 is 48. 24 into 2 is 48. So your LHS and RHS both are matching. Hence the associative property holds good for multiplication too. Finally, let's check out division. So you have a divided by b divided by c is equals to a divided by b divided by c. So what are the values of a, b and c? 10, 2 and 5 respectively. So this is the equation. So what are you going to do first? Solve the bracket first. So this is nothing but 10 divided by 2 into 5 will be what? You are going to inverse and multiply. This will be what? 2 upon 5. So 2 upon 5 will be inverse and multiply 5 upon 2. So again, if you are not aware how this changed from 10 into 5 by 2, you can check out the rules of addition and subtraction over here. Again, there is a separate video, what happens when you multiply 5 by 5 and this thing cross multiplication concepts also have been explained. So this 2 upon 5 is as good as 2 upon 5, and when you have 10 into 2 upon 5, it will inverse and multiply. So you have solved the bracket over here first. So is not equal to 10 upon 2 is what? 5. So you have 5 upon 5 on the right. So 10 into 5 upon 2 is what? 2 5s would be 10. 2 5s are 10. So 5 5s are 25 on the left hand side, and 5 divided by 5 is 1. So the LHS and RHS is not matching, hence the associative property does not hold good for division. So you can see over here associative property holds good for addition and multiplication, wherein the numbers where is it here, does not change. The associative property states that the way in which the numbers are grouped. So here you can see these numbers are grouped as B and C and A and B. So when these numbers are grouped, the value does not change irrespective of the grouping done for addition and multiplication, but it does for subtraction and for division. Finally, let's move on to the distributive property for natural numbers. And what does it state? The distributive property states that multiplication distributes over addition or subtraction. So what does this mean? Let's take addition example over here. So multiplication distributed over addition. So let's how with the equation? A into B plus C is equals to A plus B, A into B, sorry, plus A into C. What does this mean? When you have such an equation, what are you going to do? A into B, here A into B, you put it under brackets, then there is a plus sign over here, then A into C. So that's how the distribution takes place. Now let's check out a few examples. So the values of A, B and C over here is 4, 3 and 5 respectively. So we have just written down the equation over here. So using BODMAS, what are you going to do? 5 plus 3 is 8 over here and 4 3s are 12 over here, and this bracket is 20. So 8, 12 and 20. So again using BODMAS, what is this over here? 4 8s are 32 and 20 plus 12 also is 32. So your LHS is equals to RHS, hence the distributive property for multiplication over addition holds good. Then you have multiplication over subtraction. So here is another equation. A into, you can see instead of positive we have negative, so A into B minus C is equals to A into B minus, which is the sign over here, A into C. Let's check out the values. 4 into 5 minus 3. So when you go to solve the brackets first, you'll have 2 over here, 20 over here and 12 over here. So you see 4 into 2 is 8 and 20 minus 12. 4 5 is 20, 4 3 is 12 is also 8. So you have 8 on the LHS, 8 on the right hand side. So yes, the distributive property for multiplication over subtraction also holds good. So this is a closure. This is a tabular table for the natural numbers over here. So you can see these on in the columns you have the properties, and on the LHS the operations. So you can see that the closure property holds good for addition and multiplication, but may or may not hold good for subtraction and divisions. So likewise the commutative property holds good for addition and multiplication and may or may not hold good for subtraction, division. The associative property also over here is holds good for addition and multiplication and may or may not be for subtraction, division, whereas the distributive properties hold good over addition. It has over addition over subtraction, multiplication over addition and multiplication over subtraction. So I hope that this made clear to you how this property works for natural numbers. You can check out the similar closure properties for rational numbers, for integers and for whole numbers too. You can find the descriptions links in the description over here. So please do like the video, do share it across, and before I can wind up, a humble request: if you have not yet subscribed to my YouTube channel, I would request you to kindly do so now. Until the next video, take care and be safe.